Good morning. Welcome to KubeCon. This is the largest KubeCon yet. I am very excited to give you an update on the Kubernetes project and also some of the innovations that Google and others have been adding to the roadmap. So let's get started. I think everyone knows that Kubernetes is a fast-growing, fast-moving project. We've clearly won some developer love with over 35,000 stars on GitHub. And in the last year, it's second only to Linux in number of PRs and number of issues. But perhaps more important, we've also matured technically. And that's evidenced by the certification program, the conformance test suite, that helps you know that the version of Kubernetes you're using is in fact compatible with others. These are major milestones and achieved in just 3 years. But I think the question on everybody's mind, everyone here, and of course all of us, is how well is Kubernetes adopted? How many users are using it? This is hard to gauge, actually. There are a number of different surveys, and it appears that roughly half of even the Fortune 100 enterprises are using Kubernetes in some shape or form. And that seems to be true across most industries. That's heartwarming, that's encouraging, but our ambition for Kubernetes is actually much greater. So why are enterprises so important? Well, personally, I've been working in enterprise systems since graduating from college. About 5 years ago, I decided to make a change. I moved to Google to work in consumer software because I thought enterprise systems, it's a little bit slow, sometimes a little bit outdated, there's a lot of waiting involved. Consumer systems, really fast-moving. Well, little did I know. I found out at Google that enterprise systems can actually be quite fast-moving as well. And I met the folks who started Kubernetes at Google, and I realized that this community has a big dream. Here's our dream. What if enterprise software could be more like consumer software, with the same agility, efficiency, and global scalability? This is the transformation potential of Kubernetes for everyone. And we're just getting started on this dream. So in the community and also at Google, we interact with a lot of users. At Google, with GKE, we have over 100,000 nodes under management. And the feedback that we hear from users helps us shape the roadmap for Kubernetes. Some of the things that we hear this year in particular that are important to enterprises. Number 1, security. Number 2, greater breadth and scope of applications that can run on the platform. Number 3, a better developer experience. So I'm going to give you an update on where we are with each of these areas and what our roadmap is. Let's start with security. SIG has made tremendous progress in the last year and a half in beefing up security in Kubernetes. So today, you can set policies at a very granular level on which user, which pod, which application can do what and speak to which other resource in your cluster. Network policy, RBAC stability, pod security policy. Also, we've covered some of the basics, like encrypting your secrets and rotating your certificates. This is tremendous progress. But as a user, how do you consume this security? Well, one thing that's probably apparent is you have to upgrade. Not only do you have to upgrade your master, you have to upgrade your nodes. And you have to do it quite frequently. Thinking back to my experience in the enterprise, upgrades were not fun. It's not something that we did frequently. So how do you reconcile this? Well, on GKE, some of the things we've done is we've built secure defaults into the system. But more importantly, we've worked on making upgrades seamless so that the application has no downtime when the cluster upgrades. And that's work that we've done and contributed back to the open source. Again, features are important for making them usable and easily accessible to the users is more important. Another area of security is threat detection. So you've got your production application running. How do you know if there's a threat? How do you know if there's someone crypto mining in your cluster? That's actually not within the purview of the core Kubernetes project. But fortunately, there's an ecosystem of vendors, and this is just a list of some of them, that have started building threat detection software with containers and Kubernetes specifically in mind. So as a user, how do you obtain this easily? That's a good question. What we've done in Google is we actually have a single pane of glass that is the Cloud Security Command Center. Most clouds have something like this. It's one place where you can see all of the alerts and security-related threats that may be present in your network, in your storage, in your compute. Obviously, since GCP is so big on Kubernetes, Kubernetes engine and containers are a first-class resource in this command center. But again, more importantly, we're bringing this ecosystem, Aqua, Capsulate, StackRock, Sysdig, and Twistlock, as the first initial set of partners integrated into the security command center. This type of technology is not deep, but it's actually really important to make security usable. Speaking of innovation, you know, one of the problems with containers is that they don't actually contain very well. And so that's a problem for enterprises. Today, containers speak to a kernel that is a privileged kernel, and you have many different applications that share a kernel. This leads to benefits like, you know, efficiency, high utilization, and of course, fast startup. But there's actually a large surface area of resources that are exposed, despite C groups and namespaces. And there are frequent kernel vulnerabilities. So the chance of an application or container escaping and impacting some other workload is not negligible. Well, there's some work going on in SIG node to specify a sandbox container specification. What are sandbox containers? They basically offer a greater level of isolation between your applications within the same host kernel. One way to implement sandbox containers is to use a hypervisor. And that has a full kernel inside the hypervisor. So now you're back to one container or one pod per VM. This is great for isolation, but then you lose the benefits of the low memory footprint, not having a full kernel, and the fast startup. Really, what users want is the benefits of containers, high utilization and high productivity, along with hypervisor-level isolation. So how can we get that? Well, obviously, we've been running containers for many years at Google, 12 plus years and billions of containers. So we know how to do this. Yesterday, we open sourced that technology. It's called gvisor, and I think it's potentially the biggest innovation since Kubernetes itself. What does it do? gvisor is a microkernel. It's a very lightweight kernel, and it actually runs in user space without privileged access. And so it does a lot of what a hypervisor would do. It intercepts syscalls, and it watches them, but it doesn't have the overhead of a hypervisor. And so it retains some of the benefits of fast startup and high utilization. And this is available now on GitHub. I think it has several thousand stars already. And it works out the gate with Docker and with Kubernetes. We're looking forward to collaborating with the community to make this well adopted in enterprises. That's all I'm going to say about security. I think you can see that we're really making tremendous progress. The second objection tends to be applications. How many applications can run on this platform? We don't just want stateless applications. Obviously, containers are good for that. But what about batch? What about machine learning? What about stateful applications? Well, SIG Apps has made a tremendous amount of progress in this area over the last 2 years. Batch workloads with cron jobs, and now with Spark support. Big data with Spark. There's now native support for Spark, and Kubernetes is a scheduler for Spark. I'll show you a demo of that in just a few minutes. Secondly, GPUs. GPUs and hardware accelerators are critical for HPC and machine learning. And machine learning is becoming a huge workload for Kubernetes. As machine learning takes off, people don't want to have to manage the GPUs and the underlying infrastructure, not at the level of granularity that some of the brain researchers do. And Kubernetes is a great platform for abstracting away that infrastructure. What we've done in addition to the GPU support in GKE is we've added the constructs of advanced scheduling, so taints and tolerations, pod affinity, and auto-scaling, so you can auto-scale your GPUs with the usage that you have from your machine learning workload. Those are some pretty nifty things. And then back to the bread and butter, stateful applications, databases. That has actually moved to GA. Again, a lot of work by many members of the community over the period of 2 years. And we continue, actually, in SIG storage with adding local storage support, so you get high performance with your stateful applications. And finally, with the container storage interface. This is great, but we're not stopping at GA. We're actually going to make stateful applications much more automated and easy to use. And that's important. The concept here is that of application operators. What's an operator? Well, traditionally, an operator is a person. It's a person that does backup and restore. They monitor and scale the application. If you think about databases, that's usually the DBA. But in the world of Kubernetes, it's a piece of software. It's something that automates the deployment and management of the application in your cluster. What's more exciting, actually, is that the operator extends the Kubernetes API for the application. So through the use of a custom resource definition, the operator basically makes it so you can speak your application to Kubernetes itself using kubectl. So I'm not going to try and talk about that. I'm just going to give you a demo. So if we could switch over, I'm going to be demonstrating the Spark operator that was developed at Google. Let's see if we can switch over to my laptop. All right, here we are. Reconnect here. So we have a cluster here in GKE. It's called Cluster 1. And as you can see, it's a pretty beefy cluster, but it doesn't have any workloads running. And what we're going to do is we're going to go ahead and the Spark operator is open source. It's available in GitHub, and so I've cloned the repo, and I've got the YAML for the Spark operator. So I'm going to do kubectl apply -f Spark operator. And what that's going to do is it's going to deploy the Spark operator as a deployment. But normally, if you were to deploy the Spark application in Kubernetes, there would be a lot of config involved. And it could take quite a bit of time to deploy the application. All right, so now the Spark operator is created. So if I refresh here the UI, I see that the Spark operator is created. So it's actually in one command actually deployed Spark, made it look really super simple, which is how it should be. You can imagine doing this for any stateful application. But it's also extended the Kubernetes API, so I can now run Spark jobs directly using kubectl. And I'm going to show you that. I have another YAML here, which is the BigQuery word count YAML. And so let's look at this YAML. You can see that this YAML is using a new API kind, which is called Spark application. And so it's depending on that extension. And what it's going to do is, it's a Java application, running in cluster mode. But what it's going to do is it's going to pick all of the works of Shakespeare, and it's going to do word count. It's going to say, OK, across all the works of Shakespeare, how many times does a particular word appear? It's less important what the application is, but what it does is it uses BigQuery and then puts the output in a system bucket in Google Cloud Storage. And so let's go ahead and run this application. OK. And here all I need to do is kubectl apply -f, now BigQuery. And what we'll start to see here is that the system is creating Spark it's creating a Spark driver and Spark executor pods. And so these pods have started to initialize in the cluster. And they're going to start running these Spark jobs automatically. And I will start to have, in Google Cloud Storage, I'll start to have a new bucket here. Well, soon. It hasn't yet completed. Right. So we have one driver pod and two executor pods. Spark also has a master-slave architecture. And they're going ahead and they're doing this analysis of all of Shakespeare's work. And now we've got this bucket created. And if we go further into it, we will see the results, the output of the word count. I'm going to switch over to the slides to keep going. But this should give you an idea of the power of application operators. You don't have to know a lot about the application. It can be deployed automatically in Kubernetes, and then you can just hit go. The last piece in managing applications, you're going to have now many applications in your environment in one cluster, and potentially many clusters in different clouds. So how do you monitor all of that in one single pane of glass? We found that that's actually quite important. From our experience with SRE at Google, you want to have both application metrics as well as infrastructure metrics in one pane of glass across your environment. And so what we've done on GKE is we've pulled in all of the Kubernetes resources into Stackdriver, so you have one pane of glass there. But what's more important is we've actually started contributing to the Prometheus open source code base. Prometheus, for those of you who don't know, is the default metrics pipeline for Kubernetes clusters. And so many folks are using Prometheus in their on-prem clusters. The contribution that we've made there is we've created an API that allows you to pull metrics and stream them to the cloud. And so in GKE, we stream the metrics from on-prem clusters using Prometheus to provide one pane of glass where you can see all of your clusters and both application and infrastructure metrics. What does that combination give you? Well, there's many examples. You can use application metrics to trigger the horizontal pod autoscaler. You can use application and infrastructure together to debug your application. These are some of the simpler innovations, but they're really important, again, for usability and broader adoption of Kubernetes. The last thing I'm going to cover is developer experience. So there's been a lot of talk about the developer experience of Kubernetes and whether it's truly as good as it could be, and I think it's not. If you think about what a developer does, they're writing source code somewhere over here on the left, and then there's Kubernetes that's been installed and is managed for them, for their benefit, so that they can do this many times a day. But there are so many steps between the writing of the code and the deploying of the application that developers are often the last people to interact with Kubernetes. There's building from your code, building the image, pushing it up to the repository, pulling it down from the repository, deploying it to Kubernetes. And right now, there's many different ways of doing this, many different tools, many different choices. There's no one well-lit path for this process. And I'm not going to say that there is, because there isn't, and there's a lot of work in the community to fix this or to improve this experience. But and actually, this experience goes on. If you're a developer, you do this many, many times a day because you're making changes. But there's a project that has recently been open sourced. Actually, it was developed by one of our customer engineers at Google. So this is very much customer friendly. It's called Scaffold. It's a small project, and I'm going to give you a demo of it just to show what this developer experience could be in the future. And I demo Scaffold because in the 2 months that it's been out, it has more than 3,000 stars. So it must be somewhat useful to some number of people. If we can switch over to my laptop. So we're back in our cluster, and there's actually, this is the Scaffold directory. And I'm going to pretend to be a developer. What I'm doing is I'm working on this application called main.go. It's a very simple application. It just says, hello, KubeCon. It prints hello, KubeCon. And so now I don't know much about Kubernetes. There's a cluster out there somewhere. OK, I don't really want to know all of the things that I need to do. Just let me run this and change it and iterate. So with Scaffold, all I do is I say Scaffold, and I run it in dev mode. And Scaffold actually looks for for whatever Docker file is available in the directory, and it goes through and it finds all of the images, and it starts to build the images. So this is what it's doing right now, and you can run Scaffold locally on your Mac, or in this case, we're running it against a Kubernetes cluster in GKE. And so it's using Container Builder, which is the built-in functionality in GCP, and then it's pushing the image up to GCR, Container Registry. The nice thing about this is your developer actually doesn't have to know all of this, and you can be setting policies on the registry. You can be doing vulnerability scanning and image provenance, and all of the enterprise-grade policies that you want to have around those images can be baked in to that. And so here we are. We're now live. We're saying hello, KubeCon. But the other interesting part of this is that I, as a developer, am going to go ahead and change main.go, because I'm testing it out, and I want to try something else. So I'm going to say, hello, KubeCon. Instead of that, I'm going to say, happy, I hope I can spell this, Higgy, KubeCon, Huggy, happy Huggy. And actually, Scaffold has automatically picked that up, and it's realized that there's a change, and it's going ahead, and it's OK. Actually, this time there's a problem. I haven't fully got the credentials, but what it should do is it will pick up the changes, and it'll start saying happy Huggy to KubeCon. OK, we'll switch over to the slides. So those are some of the simple examples of how we can make Kubernetes easier to use and how it can be better adopted in the enterprise. I just want to leave you with the thought that this project has a great deal of horsepower. This technology has a great deal of potential to transform enterprises. And the roadmap that we have for this project now is very much based on user adoption. And we're doing things both complex but also simple to make it so much more usable by so many more audiences. Thank you.